So we have an expression of this kind, whole to power 5, and they say that the third term here is 1000. We want to be able to find x. We want to be able to find x such that the third term is 1000. A third term means what? Tr plus 1, which is 5c2, a, which is 1 by x to power n minus r, 3, into x to power log x to the base 10 whole squared. Yes or no? And that is given to be 1000. Right? 5c2 is 10, so that will make this 100, right? And this will become x to power 2 log x, right? 2 log x to the base 10 minus 3, right? That must be 100, because 5c2 is 10, 1000 by 10, right? Now what you could do is, you could take log of both sides. Take log of both sides to the base 10, then this will be 2. If I take log to the base 10, this will turn out to be 2, isn't it? Right? So then, I have, if I took log of both sides, then 2 log x to the base 10 minus 3 into log x to the base 10 is log 100 to the base 10, which is 2. Log of x to the power 2 log x to the base 10 minus 3 is log 100 to the base 10, right? This will be 2. X to power m would be m log x. So we have like a 2 log x to the base 10 minus 3 log x, right? Log of x to the power m is m log x, isn't it? That's a property that we used here, right? That's what we. So now what you can do is you can take log x to the base 10 as t, get a quadratic in t and solve for t. Yes or no? Take log x to the base 10 as t, and then we have like a 2t minus 3 into t equal to 2. Produce a quadratic in t and solve for t. And once you know t, plug in the value of t, and x would be 10 to power t. That's how you take. Right? Let me explain 4. N is a positive integer and 1 plus x square whole to power n is summation ar x power r equal to 0 to 2n. Now we have the following propositions to take care of. 1, ar is the same as a 2n minus r. That's the first thing. If you recall, I had established this in my class, basic class on binomial. Replace x by 1 by x and equating coefficients, but I'll redo that if you want. Second part, a naught plus a1 plus a2 plus a n minus 1 we want to show is equal to 3 to power n minus a n by 2, right? That's the next part of the problem. The third part of the problem that we want to take care of is r plus 1, ar plus 1 equals n minus r ar plus 2n minus r plus 1 ar minus 1 for r greater than 0 less than 2n, right? Okay, even though the first part of the problem I had done before, but I'll still redo it so that you know it comes live to your memory. So 1 plus x square whole to power n, essentially when we say ar is a 2n minus r, that means a0 would be a 2n, A1 would be A, 2n minus 1. A2 would be A, 2n minus 2. A3 would be A, 2n minus 3. That means coefficients of terms equidistant from the beginning and end is the same. The methodology to establish this is by saying replace x by 1 by x. Replace x by 1 by x. Now, if I replace x by 1 by x, then what do we get? 1 plus 1 by x plus 1 by x square whole to power n is summation ar 1 by x to the power r equal to 0 to 2n. Yes or no? Multiply throughout by x power 2n, right? So when I multiply throughout by x power 2n, I again get 1 plus x square whole to power n is that x power 2n. When I multiply, you know, since it's independent of r, it'll have a thoroughfare into the summation sign. It'll get into the summation sign, yes or no? X power 2n. See, if it's independent of r, it has the luxury of coming out and going in as per choice, right? So x power 2n goes in. You know what I'm saying? I'll repeat now. I'm saying I'm multiplying throughout by x power 2n. Right? When I multiply this by x power 2n, I get this. When I multiply this x power 2n, then this can come inside the summation sign. See, x power 2n into some terms, term 1 plus term 2 plus term 3, etc. So it can come into, it can break past this parenthesis, x power 2n into 1, x power 2n into 2, x power 2n into 3, and so on and so forth, right? Any term which is independent of r can come in and go inside. See, summation k times ar is k times summation ar. So k can stay in or stay out, right? If k does not depend on r, x power 2n does not depend on the running variable r, so it can be in or stay out, right? Okay. So right here then, this is going to be summation ar x to power 2n minus r runs from 0 to 2n, r runs from 0 to 2n, yes or no?
Yes.
Hello, right? Hey, but 1 plus x square whole to power n is what? Summation ar x power r? Summation ar x power r, yes or no?
Yes.
Right, so left hand side I rewrite as summation ar x power r equal to 0 to 2n. That's the left hand side. Clear? And the right hand side is summation ar x to power 2n minus r equal to 0 to 2n. Right? Sounds good? Now, what's the coefficient of x power? So, these are identical polynomials, right? So, coefficient of x power London here would be the same as coefficient of x power London there, yes or no? Right? What's the coefficient of x power r on the left hand side? Coefficient of x power r on the left hand side is simply going to be ar. Is simply going to be ar. Right? And that must be the same as coefficient of x power r on the right hand side, right? Can I just wipe this off, this portion? So ar, which is the coefficient of x power r on the left hand side, must be the same as coefficient of x power r on the right hand side. That is in summation ar x to power 2n minus r runs from 0 to 2n. Yes or no? Now, do you realize that AR x to power 2n minus r is actually A 2n minus 2n minus r x to power 2n minus r? Yes or no? Isn't it? This r can be written as 2n minus r x to power 2n minus r, right? So, coefficient of x power London on the right hand side, coefficient of x power London on the right hand side is A 2n minus London. You know what I'm saying? Coefficient of x power London, this is London, 2n minus r, treat that as London. A 2n minus p x power p, yes or no? Is that not of this form? A 2n minus p x power p, that's the right hand side, that's what the right hand side is all about. A 2n minus p x power p, right? So coefficient of x power p is going to be A 2n minus p. Coefficient of x power q is going to be A 2n minus q. Coefficient of x power r is going to be A 2n minus r. Yes or no? So coefficient of x power r on the right hand side is going to be A 2n minus r, right? Right? So it's going to be A 2n minus r. So AR then turns out to be A 2n minus r. A0 will be A2n, A1 would be A2n minus 1, A2 would be A2n minus 2, A3 would be. Coefficients of terms equidistant from the beginning and end in this case is the same. In this expansion is going to be the same. Is it bothersome? No? Now the last part. So far so good, right? Okay, let me explain this. This one is a very simple part of the problem. We are done with this part 1. AR is A 2n minus r. Clear? Now, can I wipe this portion off? Have I left some of you confused? No? Confusion? No? Okay, no, that's fine. See, what is it of AR is actually A 2n minus r x power 2n minus r, right? That's the general term of this summation. Clear? What is this like? This is like x power p 2n minus p. Is it not? This is like x power p A 2n minus p. So what is the coefficient of x power p on the right hand side? A 2n minus p. What's the coefficient of x power t on the right hand side? A 2n minus. What's the coefficient of x power London on the right hand side? A 2n minus London. What's the coefficient of x power r on the right hand side?
But then that's a different r and this is a different r, right? Like how can you...
Does not matter. I mean, coefficient of x power r will still be this.
It's like you're replacing 2n minus r with r.
No, yaar, I'm just doing this. I'm writing this as x power p 2n minus p. R is a running variable. It's not a fixed number anyways. I'm writing this as x power p A 2n minus p. Where p can take values like 0, 1, 2, 3, etc. No, not very sure, na? Okay, if you're not very sure, I'll quickly do this for you. Let me find the coefficient of x power r on the right hand side without doing this jugglery. Okay, let me do it the brute force way. Coefficient of x power r in this, right? A0 x power 2n, A1 x power 2n minus 1 are equal to A2 x power 2n minus 2, A3 x power 2n minus 3, an A2n. That's the right hand side. Now what was the left hand side? The left hand side was A0 plus, see, the left hand side was just this, right? A0 plus A1x plus A2x squared plus A3x cubed plus A2n x power 2n. That's the left hand side, right? These two are identical polynomials. So do you realize the coefficient of x power 0 here must be equal to coefficient of x power 0 there. Coefficient of x power 1 here, a1. a 2n minus 1 x. Coefficient of x power 1 here, a 2n minus 1. Coefficient, so a2 would be a 2n minus 2, a3 would be a 2n minus 3, ar would be a 2n minus r. Is this okay? Very good. Fine. Shall we proceed then? But I still recommend, I recommend you to not do this, but do what I suggested earlier, because that way, you know, you gather some mental maturity towards this summation notation and stuff. So I want you to be more comfortable with the other stuff. This is all right. This will always work, right? Can I wipe this off? Now this part, a naught plus a1 plus a2 plus an minus 1. Obviously, you know, I'll put x equal to 1, right? Put x equal to 1 on both sides in this identity. So I get like a 3 to the power n equal to a naught plus a1 plus a2 plus a3 plus an minus 1 plus an plus an plus 1 n plus 2 a2n. Yes or no? Hey, realize that this sum is the same as this sum. Why? Because a naught will be the same as a2n, a1 would be the same as a2n minus 1, a2 would have been the same as a2n minus 2, an minus 1, this last term an minus 1 would have been the same as a 2n minus n minus 1, which is like a n plus 1, right? So this term would have been the same as this term. That means this is the same as this, right? Right? And this is isolated, left out. Siddhant, don't worry, we'll bring you back. Put x equal to 1, 3 to the power n, a naught plus a1 plus a2 plus a3 plus an minus 1, and then plus an, and then an plus 1 plus an plus 2 plus an plus 3 plus a2n. Shall I, are you okay with this now? This is the same as this. So this plus this would be twice this plus an, right? So twice the required summation plus an plus an is 3 to the power n, right? This an is unattended, and all that you need to do is transpose s would be 3 to the power n minus an divided by 2 would be the required sum. This. I don't have a problem explaining again if you've lost track of it. Trust me. Are you fine with this? Sure? Okay. Now the last part of the problem. Now, this one, relating AR with AR minus 1 and AR plus 1, right? These are three neighboring coefficients, isn't it? These are three neighboring coefficients. AR minus 1, AR and AR plus 1 are three neighboring coefficients for floating R. R varies from 0 to 2n, but AR minus 1, AR plus 1 would be neighboring coefficients, three neighboring coefficients. I want to connect them. Now, we'll have to get a clue somewhere, you know, how to bring about this. And we are perhaps not sure, prima facie, as to where to head. But one term, see, there is a RAR, right? There is a RAR appearing here, which is about differentiating this with respect to x, you will get RAR, isn't it? RAR x bar r minus 1. When you differentiate this with respect to x, will you not get RAR x bar r minus 1? Right? Right, so that gives us an initial ray of hope on how to proceed with this situation, right? Let me differentiate with respect to x. If this doesn't work, then something else will, right? Let's differentiate with respect to x and take chances, right? So, of course, I will assume you all know how to differentiate chain rule, product rule, etc., right? So, when I do that, then I get n into 1 plus x square whole to power n minus 1 into 1 plus 2x. Is that the derivative of the left hand side or not the derivative of the left hand side? No?
Yes.
That's the derivative of the left hand side, right? The derivative of the right hand side, derivative of the sum would be sum of the derivatives? No. Huh? Why? Differentiate this to power n with respect to this. So you get n into 1 plus this to power n minus 1. And then differentiate this with respect to x, you get 1 plus 2x. Right now? No? And see, ddx of a summation would be summation of the ddx's, yes or no? Derivative of the sum would be sum of the derivatives. So they are interchangeable operations, right? So I pose it as follows: RAR x bar r minus 1 r equal to 0 to 2n. Yes or no? Does it make sense to you so far? Yes, I will. ddx of f1 plus f2 plus fn is ddx of f1 plus ddx of f2 plus ddx of fn. Yes or no? This is what? Summation fr. This is summation of ddx of fr. Yes or no? This is ddx of summation fr, and this is summation of ddx of fr. Derivative of a sum would be sum of the derivatives. No? Still lost? Yes? Lost? You saying yes to that? So ddx of this would be summation of ddx. Clear? Now, I multiply throughout by 1 plus x square. Then I get n into 1 plus x square to the power n into 1 plus 2x is the left hand side when I multiply with 1 plus x square, right? And the right hand side is going to be summation is 1 plus x square summation r equal to 0 to 2n RAR x bar r minus 1. Yes or no? Simple now? Now, 1 plus x square to power n is actually summation AR x bar r. Right? This 1 plus x square to power n is actually summation AR x bar r. So, n into 1 plus 2x, you know this I bring together, n into 1 plus 2x, and this I write as summation AR x bar r equal to 0 to 2n. That's the sum total of the left hand side. right? And the right hand side is 1 plus x squared summation RAR x bar r minus 1 r equal to 0 to 2n. Yes or no? Clear? Okay. Can I just remove the clutter from here? Okay. Let me attempt to equate coefficient of x bar r on both sides. Let me attempt to equate coefficient of x bar r on both sides. This is an identity. So coefficient of x bar r on the left hand side must be the same as coefficient of x bar r on the right hand side. Clear? Equated will give the following. Look, I have a x bar r that will have a coefficient AR. AR into n. That's one way to get x bar r, isn't it? N into 1 into AR x bar r. That's one way to get x bar r, right? And its coefficient would be NAR. Now, not only that, when x is multiplied with x bar r minus 1, that will also give me x bar r. When x is multiplied with x bar r minus 1. Now, this will be x bar r minus 1, then this will be AR minus 1. Yes or no? So, AR minus 1 into 2 into n would be another way to get x bar r. Right? NAR plus 2 into AR minus 1. Please be very sure about this. Not sure, na? See, this has terms like AR x bar r. The next term would be, say, this is the general term, right? This is the general term. The term after this would be AR plus 1 x bar r plus 1. The term prior to this would be AR minus 1 x bar r minus 1. That's the spread of terms here in this summation, right? Now to get x bar r, I have n into 1 and I should seek x bar r in this summation, which is AR. So one way to get x bar r is AR into n into 1. AR into n into 1, right? Now, then this x, in this summation if I seek x bar r minus 1, which when multiplied with x will give me x bar r, right? So then coefficient of x bar r minus 1 will be AR minus 1. AR minus 1 into 2 into n will also give me x bar r. No? No? Sure, no? So, which is this? 2n into AR minus 1 will also give me x bar r. What? Are you fine with this, all of you? No, not sure, no? This silence is deafening. Either you've mostly understood this or understood nothing about it. See, don't worry. I'll quickly. I know because there is some semblance of doubt on your faces. Think about this. This is n into 1 plus 2x. Okay. The terms here are like a0 plus a1x plus a2x squared plus AR minus 1 x bar r minus 1 AR x bar r A2n x bar 2n, right? Do you understand this? Huh? Now, how does one get x bar r here? I take this AR into n into 1. Will that not give me x bar r? And then I take this x bar r minus 1 into x. That will also give me x bar r. And then the required coefficient would be AR minus 1 into 2 into n. Yes or no? Which are the two terms here? Are you still uncomfortable with this? No? Then why do you look dilapidated? In sync? Yes or no? Yes. Thank you. Now, so the coefficient of x bar r on the left hand side is this, right? Now on the right hand side, look, there is a x bar r, which when multiplied with 1 will give me x bar r into AR. So that's one way to get x bar r, so AR. Now, x, I would have to seek x bar r minus 1, and the coefficient would be a r minus 1. So plus a r minus 1. Yes or no? X square, I would have to seek r minus 2. Hey, sorry, I didn't write the right hand side properly. What was the right hand side? 1 plus x square summation r AR x bar r minus 1. R runs from 0 to 2, and this was my right hand side. Sorry, I'll just redo this. Right. Sorry, that was my right hand side. I'm seeking coefficient of x bar r on the right hand side. Now, 1 would have to be multiplied with x bar r. Now, when this is r, this would be 1 more than this, isn't it? So it will become r plus 1 a, r plus 1, isn't it? See, these subscripts are 1 more than the power of x. So when this becomes x bar r, this will become r plus 1 a, r plus 1. Yes or no? Which when multiplied with 1 will give me x bar r. Yes or no? Yes. Right? So one way to get is r plus 1 a, r plus 1. Right? Now, x would have to be multiplied with this only to give me x bar r. So that will be RAR. That will be RAR. Right? X square would have to be multiplied with r minus 2, x bar r minus 2. Now when this is r minus 2, this will be r minus 1. Isn't it? When this will be r minus 2, this will be r minus 1. Isn't it? So plus r minus 1 a, r minus 1. Clear? And then r plus 1 a, r plus 1 is n minus r a r plus 2n minus r plus 1 a, r minus 1, collecting terms. This is what we get. Clear, na? Does not matter. See, you are beginning to grow in the sense, you know, right now there is a build-up period for binomial theorem that you are developing. So then you get a hang of things. Okay, now this is one of the things that we could have done. So equating coefficient of x bar r is one of the things that would work here. And then one clue would be RAR. And then, you know, down the line, once these elements come through to you, it's not like, you know, when you're a beginner, you would necessarily be able to do it. But as when you were a child and you were taught how to add 9 plus 7, you did this 9, 10, 11, 12, right? But now 9 plus 7, do you do this? But you are not taught this. What you do now was not taught to you. So how did you develop spontaneity? By exposure. So exposure builds spontaneity. That's how it happens. It's not that you have to be born with it. Right? It's not like when your parents taught you how to add 9 and 7 and right away rubbished it. 16. Why do you do me all this? No. See, one of the foundations of learning the subject of mathematics is to get exposed to variations. You know, they stay in your subconscious, and you know you can bring them out as and when required if they are there. You know, sometimes they are actively in you, sometimes they are passively in you, but you've been exposed to it sometime or the other. You know, it'll come in handy. Because, you know, you essentially, the mechanism of problem solving, essentially, when you look at a problem, either you do it from first principles, you know, you never had any knowledge of the problem or related stuff, or it's a direct application of a formula that was taught to you, or you can connect that problem to a problem that you have solved before. May not be the same problem, but you could relate to a problem that you have solved before. And that's how the mathematical profile personality in you builds. Combination of these things, right? And then once you grow past this level, the next echelon would be like a more creative echelon, where neither do you have a database of problems with which you could connect that, nor did you have the foundation for that problem, nor the first principle. You creatively develop things on your own, which would be the next level of problem solving. IIT does not require that. If you can understand the foundations right, apply first principles, apply results, and or connect to an existing situation. That is about it. And therefore exposure to a variety is a must. Whether you've been able to solve it independently or not really becomes secondary. Okay? So don't get dissuaded by the fact that there is a problem that came through and you struggled with it, you couldn't solve it. That's all right. That happens with so many people. One plus x plus 2x squared to power 20. Very clearly, highest power of x will be 40 only. You can see that, right? X to power 2 into x power 2 into x power 2 20 times. That's going to be x power 40. We want to find want to find the value of a0 plus a2 plus a4 plus a38. All right. Let me plug in x equal to 1 on both sides. Excuse me. So that makes it 4 to power 20. Plug in x equal to minus 1. You get 2 to power 20. Right? Add, because you're seeking a0, a2, etc. The odd terms will cancel. Oh my God. 4 to power 20 plus 2 to power 20 is twice a0 plus a2 plus a38 plus a40. Yes or no? Right? Now, realize this expression 1 plus x plus 2x squared whole to power 20 is like 1 plus x plus 2x squared. How many times? 20 times. And the term x power 40 is obtained as 2x squared into 2x squared into 2x squared 20 times, isn't it? 2x squared into 2x squared into 2x squared into, that's the only way you could have got x power 40. And therefore coefficient of x power 40 is going to be 2 to power 20. Yes or no? That means a40 is going to be 2 to power 20. a40 is going to be 2 to power 20. So this a40 I can replace by 2 power 20. And then you get the required sum. This is what you need, isn't it? Okay, and then look at 14. We want to find coefficient of x power 2k plus 1 in 1 minus x plus x squared minus x cubed plus minus x power 99 plus x power 100 into 1 plus x squared plus x cubed plus x power 99 plus x power 100, right? We want to find the coefficient of x power 2k plus 1 in this. right? Now to solve this problem, you never were required to attend any of my classes on binomial theorem. Not even that. Look, what I do is I collect the positive terms and the negative terms here, right? So the positive terms in the first parenthesis are what? 1 plus x square plus x power 4. These are the positive terms. And the negative terms are minus x cube, minus x power 5, and so on and so forth. So minus x. I take x common from the negative terms. X into 1 plus x square plus x power 4, and so on and so forth. I break it up into two entities. This into, now I do the same thing here. I collect the even terms and the odd terms, right? 1 plus x square plus x power 4 plus, and then the other terms x, x cube, x power 5, I take x common from those. X into 1 plus x square plus x power 4 plus. Yes or no?
Yes, sir.
Tell me. Yes, absolutely. A minus b into a plus b, which is a square minus b square. Yes or no? Now notice that in this expansion you will have only even powers of x appearing here. 1 would be there, right? Other than that, they would be all even powers of x. See, 1 plus x power 4 plus x power 8, or taking 2 at a time, let's say 2x power 6, 2x power 4, x power 6, etc. Those kind of terms, yes or no? Yes. You will have only even powers of x appearing here, right? In this is even, and this will produce even powers of x. So this into this will produce only even powers of x. That means this entire sum does not produce odd powers of x. That means coefficient of odd would be 0. Coefficient of x to power 2k plus 1 will be 0. See, it didn't require knowledge of binomial theorem. Prince Khoka? Yes. Did you understand this? Did you understand this? A minus b into a plus b. A square minus b square? No? When you expand this, you will have only even powers of x. Do you understand that? This will x square even, and this when expanded will also produce only even powers of x. So even powers of x, even powers of x. Are there any odd powers of x produced when I expand this? So coefficient of x power odd will be 0. Clear? Summation r equal to 0 to n minus 1 to power r NCR 1 by 2 to power r plus 3 to power r divided by 2 to power 2r 7 to power r divided by 2 to power 3r 15 to power r divided by 2 to power 4r up to m terms. This is what we are trying to do here, right? Now, hey, if I said summation r equal to 0 to n minus 1 to power r NCR x power r, what is this going to be? 1 minus x power n. Do you realize that? Yes. This is going to be 1 minus x power n. See, put r equal to 0, 1, then minus nc1 x plus nc2 x squared minus nc3 x cube. That's the kind of terms we are going to get, right? So minus 1 to power r NCR is x power r is 1 minus x to power n. Clear? Isn't it? So then we break it up into several summations. This is like summation minus 1 to power r NCR 1 by 2 to power r equal to 0 to n for this term, right, plus summation r equal to 0 to n minus 1 to power r NCR 3 by 4 whole to power r, 3 by 4 whole to power r, isn't it? This is 3 by 4 whole to power r minus 1 to power r NCR. This is 7 by 8 whole to power r. Yes or no? This is 7 by 8 whole to power r. R equal to 0 to n and so on and so forth, isn't it? That's the kind of terms we get here. Minus 1 to power r NCR x power r. What is that going to be?
1 minus
So this is 1 minus half to power r. Minus 1 to power r NCR x power r. 1 minus 3 by 4 to power r. 1 minus 7 by 8 to power r. And so on and so forth. How many such terms? M terms. M such summations. Right? So this then is like 1 minus half to power n, 1 minus 3 by 4 whole to power n, 1 minus 7 by 8 whole to power n, up to m terms. Confused? No. This is like half to power n, right? Plus 1 by 4 to power n, 1 by 8 to power n, up to m terms. What is this? With common ratio? 1 by 2 to power n is the common ratio of this GP series. Number of terms? M. Right? So the sum of this GP series is A, 1 minus, this is R, half to power n is R, whole to power number of terms M, 1 minus R to the power M divided by 1 minus R. R is half to power n. A into 1 minus R to the power number of terms M divided by 1 minus R. That's the required summation. Does it make sense to you?
So in the first step also it would have been looked upon as a GP for the denominator and the difference was in GP of the numerators. The difference of the numerators was in GP. No, that's power.
There is a power R. How? How? There is a power R. No, they are not. They are not. Let me illustrate some more. Can I wipe this off? We want to show summation k cubed nck divided by nck minus 1 k equal to 1 to n. We want to establish is whole squared is 1/12 of n into n plus 1 whole squared into n plus 2, right? Hey, nck by nck minus 1 is n minus k plus 1 divided by k, isn't it? So this is summation k cubed n minus k plus 1 divided by k whole squared, k equal to 1 to n, right? This is like summation k into n minus k plus 1 whole square, thank you, k equal to 1 to n, right, which is as good as summation k equal to 1 to n k into, this is n plus 1 whole squared minus 2k into n plus 1 plus k squared. Yes or no? Right? Which is n plus 1 whole squared summation k equal to 1 to n minus n plus 1 twice n plus 1 summation k squared k equal to 1 to n plus summation k cubed k equal to 1 to n. This is n into n plus 1 by 2, n into n plus 1 into 2n plus 1 by 6, n into n plus 1 by 2 whole squared. Plug in and simplify. Right? Sum of the first 10 natural numbers, sum of the squares of the first 10 natural numbers, sum of the cubes of the first 10 natural numbers. Is that okay? Number 18, coefficient of x power n, y power n in 1 plus x into 1 plus y into x plus y whole to the power n. We want to find the coefficient of x power n, y power n in this expansion. Right? Just expand it a little judiciously. This is 1 plus x power n, which I can write as nc0 plus c1x plus c2x squared plus c3x cubed plus cnx power n, right? The second term. I write this as y plus 1 to power n. So that's like a c0 y to power n plus c1 y to power n minus 1, c2 y to power n minus 2 plus cn, right? That's expansion of the second one. And then this is c0 x power n plus c1 x power n minus 1 y, c2 x power n minus 2 y squared, cn y to power n. Yes or no? Right? Hey, look. I take this into this into this. Do I not get x power n, y power n? That is c0 cubed. That's c0 cubed, isn't it? This into this into this. c0 cubed, x power n, y power n, right? I take this, I take this, and I take this. Tell me, do I get x power n, y power n? That's c1 cubed. And then I take this, I take this, and I take this. See if I'm getting x power n, y power n. c2 cubed. And going this way, look at the last one. This, and this. X power n, y power n, that's cn cubed. So this is the required coefficient. c0 cube plus c1 cube. Don't have to simplify beyond this. This would be the coefficient of x power n, y power n. Finish. Right? Then? You really want me to do 2? Okay. Can I wipe this? Oh, yeah. Which is wrong. nc n by 2 whole cubed is not this. And why do you assume that n is even? Why should nc n by 2 even exist?
So for any general term x to power n by 2 power n, can we write the number of ways of arranging it as q and c, and that's where the coefficient also comes?
No. No. In this?
Not in this.
Then?
In some
Yes, yes. In general, coefficient really means the number of ways in which you could get that power of x. That's the whole idea. Yes. In fact, my first stint with binomial with you guys was towards the end of combinatorics, where this is the whole idea that I communicated. The coefficient of a certain power of x would be the number of ways in which you could get that power of x. That's how we build binomial, right? S I greater than or equal to 0, less than j, less than or equal to n, I plus j, Ci Cj. Ci Cj means Nci Ncj. Right? Now the way we could replace I by n minus I, in a double summation we can replace I by n minus I and j by n minus j. We can replace I by n minus I and j by n minus j. The appearance of the terms will just take place in the reverse order and we'll get the same kind of terms even in a double summation. You might want to laboriously check that out independently. That means what we do here is this S I greater than or equal to 0, less than j, less than or equal to n, replace I by n minus I, j by n minus j, C n minus I, C n minus j. Yes or no? Right? Let me add these two. Let me add these two. 2s I will get cancelled with I, j with j. Why? Because Nc n minus I is the same as Nci, so this will be Ci and this will be Cj. Yes or no? That means from these two terms I could take Ci Cj common, isn't it? And then what I am left with is 2n. When I add these two I am left with 2n, right? So this is 2n summation Ci Cj. And 2n can come out of these double summation sign. And I have already told you how to deal with this, isn't it? Yes or no? Are you fine with this? This I have already discussed, right? Double summation Ci Cj. So you can just plug in. This is 2 times s. S would be half of this. 2n came out because it was independent of I and j. This is what transpired. Clear?
So how do we do sums like I is less than equal to j? There were sums like I is less than equal to j.
No, it is not possible. I am so sorry. Because the whole objective of this is to make sure that there is a Ci squared that doesn't appear in the summation. Then those terms are written as Ci squared. It is just not possible that you will have I equal to j in this notation, because then that would refer to terms like Ci squared which are written separately, not in this notation. No, it's not possible. For I equal to j, there will be separate terms. Those will be terms like C1 squared plus C2 squared plus C3 squared plus Cn squared. Take care of those terms separately. Otherwise, I is less than j. Right? In this notation, they never use I equal to j. The whole objective of this is to make sure that I and j are distinct. That's the whole objective of this notation. 22c. Slightly different notation. I equal to 0 to j and j equal to 1 to n. Ncj we want to show is 3 to power n minus 1. I equal to 0 to j, j equal to 1 to n, we want to show is 3 to power n minus 1. This is what we want to establish, right? Ncj into jci. Right? Now, almost self-explanatory what this notation is all about. Now, see, we take j equal to 1. This will become nc1, right? But when j is 1, I would be 0 and 1. I goes from 0 to j. I goes from 0 to j. So when j is 1, I will assume two possible values, 0 and 1. Yes or no? When j is 1, I will assume two possible values. So when j is 1, I will be 0 and I will be 1. That is the term for j equal to 1. That will be the term for j equal to 1. See? We are adding only, this is NCJ, JCI. I have just taken NC1 common from the two terms. For j equal to 1, the NC1 is taken common. Right? Yes or no? Now for j equal to 2, NC2, j is 2. I will assume values like 0, 1 and 2. Similarly, for j equal to 3, j equal to 3. I will take values like 0, 1, 2, 3. I go 0 all the way to j. So if j is 3, I will take values like 0, 1, 2 and 3. Does it make sense to all of you? Right? And going this way, up to j equal to n. Right? So when j is n, I will take values like 0, 1, 2, 3 up to n. I is 0, I is 1, I is 2, I is n. Yes or no? Right? NC0 plus 1C0 plus 1C1 is 2 to the power 1, right? So it's NC1 to the power 1. 2C0, 2C1, 2C2 is 2 to the power 2. Three C0, 3C1, 3C2, 3C3 is 2 to the power 3. This one 2 to the power n. Now what we do is we add a NC0 and we subtract an NC0. When I do that, then what is this? 1 plus 2 whole to the power n, isn't it? This is 1 plus 2 whole to the power n, isn't it? Right? So this is 1 plus 2 whole to the power n minus NC0, which is 1. That makes it 3 to the power n minus 1. Simple, right? Let me also illustrate a little more here. Where, yaar? Where is the GP series? I don't see a GP series at all. Okay, can I wipe this off? The sum S is like NCN, n plus 1 Cn, n plus 2 Cn, n plus kCn. We want to show is n plus k plus 1 Cn plus 1. Right? Again, we will deploy the same technique here. Same technique. What is NCN? Coefficient of? In 1 plus x power n. N plus 1 Cn is coefficient of 1 plus x power n plus 1. Coefficient of x power n n? Coefficient of x power n n? N plus k, right? So this S could be written as coefficient of x power n in 1 plus x power n for this one, right? 1 plus x power n plus 1 for this one. 1 plus x power n plus 2 for this one, 1 plus x power n plus 3, going all the way to 1 plus x power n plus k. And what is this supposed to be? What is this? GP series? Right. Sorry for the interruption. Do you all understand this? Right? And this essentially is a GP series of k plus 1 terms and common ratio 1 plus x, first term 1 plus x power n. Yes or no? Right? So this is, isn't it? This is coefficient of x power n in sum of this GP series, which is 1 plus x power n into 1 minus r, which is 1 plus x, to the power k plus 1 divided by 1 minus r, k plus 1 terms.
That's right, okay, but k plus 1.
Huh, k plus 1 terms. Why?
Oh, right.
1, 2, k and 1.
Sorry.
Right? Which is coefficient of x power n in 1 plus x to the power n plus k plus 1 minus 1 plus x to power n divided by x. Yes or no? Yes. Tell me. Right? So we are seeking coefficient of x power n in the ratio. That means, when will x power n appear here? When the numerator is x power n plus 1, that when divided by x will give me x power n. Yes or no? Yes, sir. Right? So essentially we are seeking coefficient of x power n plus 1 in the numerator, because that when divided by x will give me x power n. Bless you. That will give me x power n, right?
But that can't appear in this.
Yeah, right. Right. Isn't it? We are seeking coefficient of x power n plus 1 in the numerator. You're right. Right? But like he rightly pointed out, x power n plus 1 doesn't appear here. X power n plus 1 will appear only here, because the highest power of x that appears here is n. Right? N. So coefficient of x power n plus 1 in 1 plus x to power n plus k plus 1, which is n plus k plus 1 c n plus 1. That's a required summation. Right? Is that okay or not okay? Fair enough? This is given. Summation AR x minus 2 to power r is summation BR x minus 3 to power r, and AK is 1 for all k greater than or equal to n. That means AN would be equal to AN plus 1, would be AN plus 2, etc. A2n, each will be equal to 1. That's given. For k equal to n, n plus 1, n plus 2, the AKs will be all 1. That's given in the problem. Okay. We want to establish, if this is the identity, we want to establish that Bn is 2n plus 1 Cn plus 1. Okay. Now, one level of simplification. X minus 2 is 1 more than x minus 3. Right? So, if this is t, this will be like a t plus 1. Let me simplify matters algebraically at least first. Okay? is summation BR T to power R equal to 0 to 2n, R equal to 0 to 2n. Yes or no? Clear now? Now, the right hand side, of course, is summation BR T to power R equal to 0 to 2n. What would Bn be? Bn would be coefficient of T to power n on the left hand side. That means, isn't it? Bn is coefficient of T to power n on this side. And that must be the same as coefficient of T to power n on this side. Bn, which is the coefficient of T to power n on this side, must be equal to coefficient of T to power n in this side. Yes or no? Yes. So Bn, Prakar, sure now? Bn must be, which is the coefficient of T to power n on the right hand side, must be coefficient of T to power n in summation AR 1 plus T to power R equal to 0 to 2n. Yes or no? That's an equivalent problem to take care of. Now, think of it. A naught 1 plus T to power 0. Put R equal to 0. Put R equal to 1. A1 into 1 plus T. Put R equal to 2. A2 into 1 plus T whole squared. A n minus 1. 1 plus T to power n minus 1. And then the AIs after this will all be 1. Do you realize that? AN would be 1. AN plus 1 would be 1. AN plus 2 would be 1. AN plus 3 would be 1. So the next term would be 1 into 1 plus T to power n would be the next term. AN, which is 1 into 1 plus T to power n. Right? The term after this would be A2. AN plus 2. N plus 1. This is AN. AN plus 1 into 1 plus T to power n plus 1. And going this way, A2n, which is 1 into 1 plus T to the power 2n. Clear? Yes or no? I am seeking coefficient of T to power n in this summation. That will be equal to Bn. Right? Now, notice, terms up to this are not contributing T to power n, because the highest power of T that appears here is T to power n minus 1. Right? So they are not contributing to T to power n. Only terms from this point onwards will contribute to T to power n. So I'm seeking, if I'm seeking T to power n in this, then I would ignore all terms from A0 to AN minus 1. Because they are not participating towards contributing to T to power n. Right? So then, Bn, which is coefficient of T to power n. Now not in these terms, but in terms from this point onwards. You know? T to power n in 1 plus T to power n, n plus 1, n plus n. What is this? GP series with common ratio 1 plus T, number of terms n plus 1. Perfect, perfect. So this is coefficient of T to power n in this GP series, which is 1 plus T to power n right? This is coefficient of T to power n in t plus 1 to power 2n plus 1 minus t plus 1 to power n divided by t. Hey, which means I'm seeking t to power n plus 1 of the numerator. That will give me t to power n in the ratio, right? So essentially I'm seeking coefficient of t to power n plus 1 in t plus 1 to power 2n plus 1 minus t plus 1 to power n. But there is no t to power n plus 1 that will appear here. T to power n plus 1 will appear only here, and that will be 2n plus 1 c n plus 1. Yes or no? That will be Pn.
So we could also have written straight from that 2n cn plus 2n plus 1 cn plus 2n plus 2 cn.
Yeah, but will you remember so many problems and their results? I agree with you, but if you have that many mega terabytes of memory in your hard disk, do that. Yes, you're right. It's see, before giving this problem, it's not like they will give you that problem first, isn't it? So rely on first principles more. Confused? In the infinite product, there is an infinite product like this, right? When I multiply it out, I'm seeking the coefficient of x power 702132416. I'm seeking coefficient of x to power 702132416. Huh? Phone number? Okay, 5. Huh? Okay, 9. Postal code? Where do you find this postal code? No. Right? We are seeking coefficient of this, x power this. This was actually a problem for people who just started to learn algebra, class 7 or 6 or 5, I do not know, 5 maybe. See, think about it. How does one obtain x power something, say x power 534. Suppose I want to obtain x power 534. There is only one way I can obtain x power 534. See, this is units, these are tens, these are hundreds, then you will get thousands. So what I'll do is x power 500 I'll get from here into x power 30. There is only one way I can get from here, x power 30 into x power 4 and then into ones of the remaining. There is only one way I can get that. Yes or no? Suppose I wanted to get x power 6891. What would I do? There is a x power 1000, x power 6000, sorry, into 800, x power 800, and then x power 90, and then into x power 1 into one of the remaining. Do you realize that all powers of x will appear here, but appearing exactly once? Therefore, coefficient of x power London would be 1. X power Patna would be 1. So coefficient of x bar, this is going to be 1. Right? Now, yes, that's exactly, which is actually the next part. So if realize that every power of x is appearing exactly once here in this product, isn't it? So this product really would be 1 plus x squared plus x cubed plus up to infinity is this product. Yes or no?
Yes.
With every power of x appearing exactly once. Is this not the product?
Yes.
Right? And if mod x is less than 1, this would be 1 by 1 minus x. If mod x is less than 1, sum of an infinite GP series. If mod x less than 1. Clear? Confused, no? No? Right? Let's look at 30. We want to find the following summation: NC0 to NCR, NC1 to n minus 1 CR, NC2 to n minus, okay, this is 2n minus 2, I guess, 2n minus 2, then 2n minus 4. This is the summation that we are seeking. Right? We want to find the sum of this set of numbers. I mean C0, C1, C2 going all the way to Cn, going all the way to Cn. Now, do you realize that 2NCR, this 2NCR is actually the coefficient of x bar r in 1 plus x to power 2n. Right? 2n minus 2 CR is coefficient of x bar r in 1 plus x to power 2n minus 2. Similarly, 2n minus 4 CR is coefficient of x bar r in 1 plus x to power 2n minus 4, and so on and so forth. Right? That means this entire sum S, this sum S could have been looked upon as coefficient of x bar r, coefficient of x bar r in C0 1 plus x bar 2n, right? 1 plus x bar 2n minus C1 1 plus x bar 2n minus 2, C2 1 plus x bar 2n minus 4, and so on and so forth. Yes or no? Right? So far so good? Right? Now, realize that this is the same as saying coefficient of x bar r in C0 1 plus x whole square whole to power n, isn't it? Is this not 1 plus x whole squared whole to power n? C1 1 plus x whole squared whole to power n minus 1, C2 1 plus x whole squared whole to power n minus 2, and so on and so forth. Yes or no? Right? Do you get a hang of what I am doing here? This is C0 t to power n minus, it's like C0 t to power n minus C1 t to power n minus 1 plus C2 t to power n minus 2 minus and so on and so forth, where t is 1 plus x whole squared, yes or no? Which is what? Which is t minus 1 whole to power n, yes or no? Is it not t minus 1 whole to power n? Right? Where t is 1 plus x whole squared. Where t is 1 plus x whole squared. So this would be this would be what? 1 plus x whole squared minus 1 minus 1 whole to power n. Right? When I simplify this expression, this would be like 2x plus x squared whole to power n. I'm expanding this. 1 will get cancelled. 2x plus x square whole to power n. Right? So this whole thing is like coefficient of x power r n 2x plus x square whole to power n. Sounds good? Right? Can I just create room by wiping that off, that portion? So the equivalent problem is about coefficient of x power r in this expression. In this expression, right? Now this expression could further be written as x to the power n. If I take x common, it will become x power n 2 plus x whole to power n. Now finding coefficient of x power r in the whole thing is like finding coefficient of x power r minus n here, right? X power r minus n when multiplied by x power n will become x power r, yes or no? You know what I'm saying? So essentially we have to find coefficient of x power r minus n here, yes or no? Right? Which is like saying coefficient of x power r minus n in 2 plus x to the power n right. Now see, clearly you have the powers of x that will appear here are what? X power 0, x power 1, x power 2. Negative powers of x will not appear here, right? So if r was less than n, then this will become a negative power of x, and that power of x will not appear here. That means the coefficient of that power of x will be 0, equivalently saying. So if someone said what is the coefficient of x power minus 2, then you will say it's 0. 0 into x power minus 2, because that term never appeared in this expansion. You have only x power 0 terms, x power 1, x power 2, x power 3, x power n kind of terms appearing in this expansion. Clear? So if r is less than n, the coefficient will be 0, yes or no? If r is less than n, r minus n will be negative, and such a term will not appear in the expansion of 2 plus x to power n. How's that? Right? Therefore then we say coefficient of x power r minus n will be 0 if r is less than n, right Shashina? Huh? Is there anyone who's confused about this fact? No? Prince? No. I'm saying, what are the powers of x that appear here? X power 0, x power 1, x power 2, right? Does x power minus 1 appear? Does x power minus 2 appear? Yeah, it appears. We said 0 into x power minus 1, 0 into x power minus 2. The terms that don't appear, the coefficient of those terms is 0, right? So if r is less than n, then r minus n will be negative. Then do you have x power a negative number appearing in this? It does. We say coefficient of x power r minus n then will be 0, right? Yes or no? Right? So if r is, so it will be 0 if r is less than n. If r is less than n, it's going to be 0. Clear? What if r is greater than n? Let's examine what if r is greater than n. Clear? So when r is less than n, it's 0, right? When r is greater than n, for r greater than n,
How did this step come after x to the power into n into 2 plus x whole to the power of n, x power n r minus n?
okay. See, in the whole thing, I was seeking coefficient of x bar r in this. I was seeking x bar r in this. But seeking x bar r in the whole thing is like seeking x bar n minus r minus n here. Because if x bar r minus n appears here, that when multiplied with x bar n will give me x bar r, isn't it? No? Confused? So instead of dealing with the whole thing, I deal with this. I find the coefficient of x bar r minus n. That when multiplied with x bar n will give me x bar r, isn't it? So equivalently, I am trying to find coefficient of x bar r minus n here, because x bar r minus n into x bar n will give me x bar r. Right? Still confused? No, no? So for r greater than n, coefficient of x bar r minus n in 2 plus x whole to power n is 2 plus x whole to power n. Clear? This is what we are trying to do here. Now, coefficient of x bar r minus n would be what? nc r minus n 2 to power n minus r minus n x bar r. This is the coefficient. See, the term would be like x bar r minus n. There will be a term like this, but the coefficient will be this. This will be the required coefficient. Isn't it? So nc r minus n 2 to power 2n minus r. For r greater than n. For r less than n, we have established that it's going to be 0. Have you all registered this? Sure now? We want to find the summation S, which is C naught 2n Cn C1 2n minus 1 this is Cn C1 2n minus 1 Cn C2 2n minus 2 Cn C3 2n minus 3 Cn going all the way to minus 1 to power n Cn and Cn. Hey, what is 2n Cn? Coefficient of? In what? 2n. This is coefficient of x bar n and 2n minus 1. Coefficient of x bar n and 1 plus x bar 2n minus 2. Coefficient of x bar n and 1 plus x to power 2n minus 3. Yes or no? Yes. Weber, where are you lost? Why? 2n Cn, bhai. 2n Cn will be coefficient of x bar n in 1 plus x bar 2n. Similarly, 2n minus 1 Cn will be coefficient of x bar n in 1 plus x bar 2n minus 1 and so on and so forth. Is that okay or not okay? Does it make sense to you? Right? So we write this S. Can I wipe this off? Can I wipe this portion off? So S then could have been just rewritten as follows. S is coefficient of x power n n C naught 1 plus x power 2n C1 1 plus x power 2n minus 1 C2 1 plus x power 2n minus 2 yes or no? Clear? So far so good? Now what I do is I take 1 plus x power common from the whole thing, right? So this is like saying coefficient of x power n n, I take 1 plus x power n common, C naught into 1 plus x power n minus C1 into 1 plus x power n minus 1 C2 into 1 plus x power n minus 2 and so on and so forth. Clear? Yes, Vaibhav, ask me. Are you all okay with this?
Yes,
Hey, C naught t to the power n, C1 t to the power n minus 1, C2 t to the power n minus 2 is going to be t minus 1 whole to the power n is going to be t minus 1 whole to the power n. Yes or no? Yes. See, this term here within the parenthesis is of the form C naught t to the power n minus C1 t to the power n minus 1 plus C2 t to the power n minus 2 minus C3 t to the power n minus 3 and so on and so forth, which is what? Which is actually t minus 1 whole to the power n. Sorry? 1 plus x minus x minus 1, yes, 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 absolutely. That's exactly what it will turn out to be, 1 plus x minus 1 whole to the power n. See, t is 1 plus x whole to the power 2n. This 1 plus x minus, yeah, which is also true, precisely. Yeah, we could have done that. Perfect. So this is like t minus 1 whole to the power n, where t is 1 plus x, where t is 1 plus x. So essentially we are, so this is like x to the power n, this is like x power n. So what we are trying to seek is coefficient of x power n in 1 plus x power n into x power n. We are seeking coefficient of x power n in this. That means we are seeking coefficient of x power 0 in this. That means 1. Isn't it? Seeking coefficient of x power n in this is like seeking coefficient of x power 0 in this, because x power 0 into x power n will give me x power n. Right? See, the first term here is 1 into x power n. That's the only term that will contain x power n. All other terms will contain powers of x higher than n. See, 1 into x power n, then nc1 x into x power n plus n, so n plus 1 and then n plus 2 and then 2n, right? So the term that contains x power n would simply be 1. See, 1 into x power n, that's the only term that contains x power n, isn't it, in this product? All other terms are what? The next term here would be nc1 x power n minus 1, nc1 x into x power n will be nc1 x power n plus 1. No, useless. So the first term alone, so this is going to be just 1. This is just going to be 1. How about it?